Hello, my name is Jonah Nelson. I am a graduate student at Eastern Michigan University studying computer-aided engineering. This semester I worked with Dr. Tony Shea to develop a code to automate convergence studies as well as batch analyses and a more robust optimization routine for Solidworks simulation that then outputs the convergence studies and correlating information to an Excel workbook. For those of you who are not familiar with Solidworks, it is a CAD package similar to AutoCAD used for 3D modeling. Solidworks simulation is an FEA or finite element analysis plugin that allows you to perform finite element analyses. As can be seen in this top image, finite element analysis takes a model and breaks it down into many small pieces, usually on the order of a few thousand to a few million. It then takes certain constraints such as fixtures or forces and is able to find the given stress in that scenario. This is a very popular tool that is used very commonly by engineers in industry. Now, when performing in-depth FEA analyses, there are generally three approaches. The first is 100% user-controlled. Now, this essentially is you sitting at a computer, or the analyst sitting at a computer for several hours to several days, making all the little changes needed in order to get all the data that they're looking for. In my opinion, this is very inefficient with time. And I've noticed that errors do have a tendency to creep in if you're not careful after working on analyses for 10, 12 hours. The second method is using built-in functions. And most FEA softwares have a built-in automation function to some level that says, I want to change this from this range to this range with this step size. I want this to be half an inch, 1 inch, 1.5 inches, 2 inches long, and run the same analysis on each of these different scenarios. And this is good, but I find it lacking. It especially lacks the ability to view the convergence studies, which I find very annoying. And I'll talk about what a convergence study is in a later slide. The third method is custom scripting. And this is the only way that I know of to get a convergence study without using the 100% user-controlled method. However, custom scripting ironically takes longer than just doing it 100% user-controlled, which is why that is a very common method. And so this semester, we endeavored to build a custom function, or custom automation function, using the custom scripting methods, so that you can have essentially a convergence study with all the features of the built-in automation function. So, in an automation function, there are three desired features. The most essential is a convergence study. I've mentioned this a few times already. This makes sure that the results are accurate. It's essentially gives you the ability to show someone the equivalent of showing your work on a math problem. So as I said in FEA, you break up a model into many pieces, and you can control how large those pieces are. So as the pieces get smaller, the results have a tendency to get more accurate. It does reach a point where you hit the limit of the computational ability of your computer, and you start to get less accurate results. But there is a point where the results essentially plateau. This can be seen in this plot here, where the number of elements, which in consequence is how large they are, as that gets larger, it eventually gets to a point where the results, or the resulting stress, more or less plateaus. And this is what is considered to be converged. Now, our program allows you to control how close you would like the results to be in order to say that they're converged. We found that 2% is a very good starting point, but I've used it down to 0.1% variance between 3 studies for convergence. Now, the second desired feature is batch routines, which run many similar scenarios with small changes. Now, the batch routine knows that it can move on to the next scenario once the scenario it's working on has hit convergence, which is why having a convergence function is so critical. Now, an example of what a batch routine is and why it's so powerful. This semester I was working on a project where we were needing to redo part of the frame of a golf cart. And I wanted to see if the material that we were considering would be sufficient if someone leaned against it. So I changed the angle the force would be applied on it from 0 to 180 degrees, incrementing every 3 degrees. So to do one study, that would take about 15 minutes, but that's 60 studies. That's 15 hours of work. I was very grateful to have a batch routine so that I could plug that in and go eat dinner while it was running. After I made sure everything was running correctly, ate dinner, worked on homework for another class, went to bed, woke up in the morning, worked on some more homework until this was done. And that was 15 hours that I didn't have to spend doing an all-nighter or spend my entire day doing repetitive analyses. And this would be incredibly powerful, as you can imagine, in the workforce, being able to have employees who are essentially working while they're more or less off the clock or at a meeting or somewhere else. Now, the third desirable feature is an optimization routine, which finds the best value in a given situation. Again, extremely powerful. This is another piece that I was using on that project. We wanted to see how thick the walls in this U shape needed to be in order for the part not to break. And we found that, given in the optimization routine, we found that we were able to drop down one standard stock size, which was absolutely wonderful. It saved us some money, saved us some time, saved us some headache in trying to get it to fit. Again, this is something that in the workforce would be incredibly useful in that you would be able to not have to guess and check and guess and check and guess and check on different analyses. Now, for those of you who are curious, my optimization routine only is able to handle a single variable at this time. It's a modified secant method that prevents the values from approaching 0 and keeps them within a manageable, a realistic size increments for manufacturing. 6 decimal points is far more than you would need for anything. But if you're curious, this is my optimization routine, and I'm using VBA for this part of the code. So, moving forward, there are several modifications that can be made to the existing code to enable user friendliness, increase modular functionality, and improve the code efficiency. For example, making the optimization routine able to handle multiple variables and optimize multiple variables. Deactivating the screen update in Solidworks is also something that needs to be done. I also could work on using a more efficient programming language, but right now we're in a phase where I'm just debugging a lot of code to make sure that everything is running correctly in an almost infinite number of scenarios. So that is our plan moving forward. Thank you so very much for your time. Have a wonderful day.